And coming at you from the Smash News Network, Least Busted David News, it's our bonus features segment. Did you know that the Total Electron Content Forecast can show you the likely places where we're expecting to see GPS errors? Now, GPS errors happen most commonly around the equator at noon. People who live at the equator don't try to use their GPSs around noon because they know they won't work. We are seeing a little bit of chaos here, and we're seeing very high levels of electron flux. We're seeing some satellite charging hazards. We'll get to it in a moment. Just let that play through one more time. A little bit of anomalous electron bands there happening around Antarctica at nighttime, but fairly orderly at the moment, and we typically do see more orderly electron bands with high levels of electron flux. Here's a diagram of the atmosphere, and what we were looking at there is the area between your GPS satellite and your handset. In other words, the plasmasphere, which is this area here, and the inner Van Allen belts. Electrons, the free electrons in those areas. Continuing on. So some significant charging hazards here, centered around 1700 hours local time. Here's a map of it. So these internal charging hazards, those are caused by the high energy electrons, the like 2 mega electron volt electron flux can get all the way into the circuitry of satellites and cause hazards, cause damage to the circuitry. So we're hoping not a lot of damage gets caused. Keep in mind those devices have safety mechanisms on them to shut down and prevent damage. Here's the 1-year chart. You can see pretty high levels of electron flux once again achieved. Here's the 3-day chart measured by the GOES 16 and 17, and we're well into warning territory. We're at like 5 times warning territory here at the moment. And the forecast model is for a slightly higher level of electron flux tomorrow. No argument there. We typically see this after we see coronal hole wind streams subside. Next, we're going to show you the ionosphere layer. The F layer is located at about 300 kilometers of altitude. This image shows you things like thermosphere temperatures, electromagnetic radiation penetration, and chemical species and their altitudes. Again, the F layer is at about 300 kilometers of altitude. It's the bridge between Earth and space. In many ways, this is the vibrational frequency in megahertz, millions of vibrations per second. Things looking pretty normal to me throughout the ionosphere. And let's look at the anomalygram to see if I'm right. Here's the anomalygram, and we are seeing some anomalies over places like South America. No real surprise there. The weakest portion of the magnetosphere is right about here. It's the South Atlantic anomaly, which may be renamed the South American anomaly, since it's right over practically the center of the continent. And some low-frequency anomalies there, mainly in the southern hemisphere. Kind of around the prime meridian, actually, interestingly enough. And some significant swings from high to low-frequency anomaly there over South America. So here's the latest image. That's 12:30 Universal Time ionogram. There's 12:30 Universal Time anomalygram. Some low-frequency anomalies happening here over the Western Pacific. Let's continue on to invite you to join the Neo-Renaissance. Have you seen our homepage, smashomash.com? You can find links below the video to it. We've got our first 9 videos for smashomash.org presents the Sun. If you like Beethoven's Moonlight Sonata, perhaps check out Part 3. You can find playlists as well at youtube.com/smashomash/playlists. Welcome to the Neo-Renaissance. Did you know we're writing a paper plausibly explaining the mechanism underlying the solar cycles in terms of polar field reversals and indeed sunspot cycles? Help us out. Consider becoming a member of the Smash team, or maybe pick up some merch. We've placed it in order of best-selling since there's been a recent shakeup, and we've actually released all of our designs. So those will be available for a limited time, folks. Probably by the time March 1st rolls around, we'll remove some of those. If there are any toward the bottom of the list that you'd like to see, pick them up now. Also, join us on Twitter. Thanks to our new followers over on Twitter. Cheers. Thanks for pressing follow. Thanks a lot, everybody. We're all the way up to 209 followers. Every time we get to 210, we mysteriously lose followers. Mainly, let's thank the Smash team at smashomash.com/Smash team. We replaced Patreon with our own superior subscription services website. We send disaster alerts and other stuff We do email pushes. Join the email list. You can even join at the bronze level for free. We've also got a silver and a gold level. They're $2.99 or $9.99 a month. Thanks again to the Smash team. Let's take a look at some ground-based solar observatory data. So here's what's going on from the perspective of Cerro Tololo, Chile. Still a massive number of filaments in the earthly zone. Check it out. Filaments, 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 filaments. Filaments over here. Lots of filaments. Underperforming sunspots for the most part. Don't be surprised to see a coronal mass ejection strike tonight, early into tomorrow. We forecasted it. Nobody else apparently saw it. I don't know how that's possible, but in any case, here's the latest intensitygram and latest magnetogram. So here's our last look for the daily space weather videos, at least of sunspot 2941. We've got another sunspot group to its south. That's also beta class. This group over here is capable of producing flares. It's beta class. This group up here is beta class, although small. That group there is beta class. That group there is beta class. And we've got a new group up here as well, also beta class. So these are all capable of producing solar flares because of their magnetic complexity, or at least associated with their magnetic complexity. All beta class sunspot groups, folks. Each one showing opposite polarity umbrae. There's the most exciting part of the closest star. It's the star of the star. Let's move on to the GOES 16 SUVI imagery. Its wide field is spectacularly great at showing solar prominences. It's ionized helium, 304 angstroms. Similar to the SDO, but with a wider field of view and a little lower resolution. Next, some more composite imagery. It's a day of composites. So this is actually 211 and 94 angstroms. It's fantastic at showing solar flares for 94 angstroms, and 211 angstroms, great at showing coronal holes. So lots of features showing up there. Keep an eye on this area down here. There's some serious plasma instability going on down there. And don't be surprised to see a bunch of ejecta come blasting out of that today. Here's 94 angstroms, one of the best wavelengths to view solar flares. It takes 10 images per minute instead of only 2, so 5 times the temporal resolution of other wavelengths. And here's the other best wavelength through which to view solar flares, 131 angstroms, along with the 94 angstroms. Thanks for tuning into the bonus features segment. Congratulations on realizing the channel exists. Don't forget to press like and subscribe if you enjoy the content. And may that solar wind be at your back.